Hi girls. Okay, so so far we've done adding and subtracting fractions. You looked at changing between improper and mixed numbers on Friday on Dr. Frost. Today we're putting those two things together and adding and subtracting mixed numbers. I'm going to go through it the same way that an exam question would look. Again, we touched on this last week, but because you do iGCSE and you have a calculator all the time, the questions won't be set up just like add these two fractions together, because you could type that into your calculator and get the answer and you haven't shown any understanding or any knowledge of how to actually do the process of adding fractions. You haven't shown you know how to do that by typing it into your calculator. So to force you to do that, the questions will always look something like these ones that I've given you here. So you've got to show that 2 and 1 over 6 plus 2 and a quarter is equal to 4 and 5 over 12. So you know the answer. They've told you what the answer is. You have to show the working out to get there. And they tend to do this with mixed numbers more often than just your standard fractions. They'll tend to put a mixed number in there to make it a little bit more challenging, and it'll be kind of in the second half of a foundation paper because it is one of the most difficult things that you could be asked to do. So let's go through how we work, or how we show this, how we show all of the steps. So the first thing you're doing when you're adding a mixed number, the first thing you want to do is change your mixed number into improper fractions. So we are going to take 2 and 1 over 6 and change it into an improper fraction. To do that, we multiply the 2 by the denominator, so by 6, and then we add on the numerator, so we add on 1. So 2 times 6 is 12, add on the 1 is 13. For now, our denominator is staying the same, so 2 and 1 over 6 becomes 13 over 6. And then we're going to do the same with 2 and a quarter. So we're taking the 2, we're multiplying it by the denominator, and then adding on the top. So 2 times 4 is 8, plus 1 gives us 9. And again, the denominator is staying a 4 for now. Then we want to make our denominators the same. So now we've got two normal improper fractions, but they're just a fraction. There's no whole number. It's just two fractions. Now we can add them together just like we were doing last week. So we need the denominators to be the same first. So we need to find a common multiple of 6 and 4. If I just quickly write out my 4 times table, I have 4, 8, 12. Now 12 is also in the 6 times table. So 12 is my lowest common multiple. So I'm going to change both of these fractions into something over 12. To change 13 over 6 into 12ths, I have multiplied that 6 by 2, and then I have to do the same to the top to make sure that fraction stays equivalent. So 13 multiplied by 2 is 26, and then I'm going to do the same with the other fraction. So to change 4 into 12, I have had to multiply it by 3, and I have to do the same to the top. So 9 multiplied by 3 makes my new fraction 27 over 12. Now I can add those two things together. So 26 add 27 is 53 over 12. Denominator staying the same. And then finally, I need to change that back into an improper fraction, because that is how they've given the answer there in the question. I have to now show that 53 over 12 is the same as 4 and 5 over 12. So 12 goes into 53 4 times, with a remainder of 4 times 12 is 48. So to get from 48 to 53, that's a remainder of 5 over 12. Notice I've still done that in my head. Like, I haven't explicitly wrote down that I've done how many 12s go into 53. Like, between this step, it's enough to just say that those two things are equal to each other. You could do that on... actually, no, my calculator doesn't. My calculator doesn't change an improper fraction to a mixed number. It'll change it to a decimal. It won't change it to a mixed number. But all I'm saying is you don't have to explicitly show too much working out between those two stages. It's enough to say that 53 over 12 is the same as 4 and 5 over 12, because all we've done is change the improper fraction back into a mixed number. And now I've shown it. Now I have, using the working out, I've shown that 2 1/6 plus 2 over 2 1/4 is the same as 4 and 5 over 12. So I'm done. I hope that makes sense. We'll do one example. It's the same thing, but with subtraction, but just so that you see it again. And then you can have a go at some exam questions yourself, because there's loads of them like this, where it's these show that types of questions. So for this one, we have 5 2/3 minus 1 and 7 over 9 is equal to 3 and 8 over 9. So again, the first step is to change the mixed numbers into improper fractions. To do that, I'm taking the whole number, multiplying it by the denominator. So 5 times 3 is 15, plus the numerator, 15 plus 2 is 17. So my new fraction, my improper fraction, is 17 over 3. And then I'm subtracting. We'll do the same again with this. So 1, the whole number multiplied by the denominator, 1 times 9 is 9, and then add on the 7 is 16 over 9. Now this time, I don't have to multiply both fractions, because if I'm finding a common multiple of 3 and 9, my common multiple is actually 9. So I can keep 16 over 9 as it is. I don't need to change it. I just need to multiply this first fraction by 3 so that they are both out of 9. They both have a denominator of 9. 17 multiplied by 3 is 51. So that becomes 51 over 9. And now I can just subtract them. So 51 minus 16 is 35. And my denominator stays a 9. The final step, change that improper fraction into a mixed number. So 9 goes into 35. 3 times 9 is 27. To get from 27 to 35, I have a remainder of 8 over 9. Denominator staying the same. And again, I have shown that I get 3 and 8 over 9 as my answer by showing all of the working out, by showing changing the improper fraction to a mixed number, making the denominator the same, and then subtracting them. I've got the same answer that they gave us in the question. It's a good way to know that you've got the right answer as well. If your answer wasn't 3 and 8 over 9, then you've obviously made a mistake, because they've told you what the answer is. So these are a really good way of picking up usually 3 marks in an iGCSE question. And you can't really go wrong. You know what the answer has to be. You just need to show the steps to get there. So you can't really go wrong with this. So today's lesson, you're going to do a bit of practice of this. I'm going to send you some actual exam questions from your iGCSE papers. Have a go at these. Make sure you're showing all of your working out, and then send them to me on Google Classroom at the end of the lesson, please. Hopefully see you soon. Should be back in school next week. But yeah, okay. Have a lovely day, and I'll see you tomorrow.